Hi, I'm DJ Ware, and on this episode of the Cyber Gizmo, we're going to take a look at computer technology, but not quite in the way you think. Instead of looking at the new shiny objects, we're going to be talking about a possible future of stagnation. So let's take a look at PC hardware standards first. So we have the ATX Advanced Technology Extended Standard, which is currently our method for deploying motherboards on PCs that we build or that you buy. The ATX Standard was released by Intel in 1995, and that includes all of its forms, from micro ATX to mini ITX. And I find it interesting that even now, 2019, gamers and PC builders are still wiring up motherboards to cases just like we did in the late 1980s. And I just think that's just fascinatingly crazy. Cases are still a mess of electrical wires, data connections, there's extension cables, there's your LEDs, and so now we've had to deal with that by coming up with a new solution called cable management. Why don't you just get rid of the cables and manage them that way? There's a thing called a bus. You could use that, and there are power buses too. Isn't that amazing? Well, at least we got rid of the flat cables that were blocking airflow in the cases. So I have a question for you. So do you really consider a 24-year-old standard to be advanced or obsolete? That question is for you to answer, not me. I think it's obsolete. There's also the EATX standard, which is the Extended Advanced Technology Extended Standard. That's the Department of Redundancy Department. Or maybe it's marketing. I'm not sure. But the EATX added 3.4 inches to the width of the motherboard. Had one problem that the screw holes in the motherboard didn't line up with the ATX cases, so you had to have a case designed for EATX. It did add dual CPU support and added some additional PCI lanes as well, or connections. But nothing in the EATX standard really helps anyone that has a home PC CPU, because none of those will support being mounted in dual processors. They don't have enough lanes, at least in the smaller versions of those. They don't have enough lanes to be able to support that many PCI connections either, or PCI sockets. They don't have enough lanes to deal with it. So really, it's not really going to be much help to you, because those boards are really designed for processors like Xeon and EPYC and Threadripper, although Threadripper doesn't do dual processor. And also some of the more advanced ARM processors. Then we had BTX, and BTX is the Balanced Technology Extended Standard that Intel introduced in late 2004 and early 2005. We went from advanced to balanced. Okay, I'm thinking maybe not marketing. Maybe that name came up was but the janitor that did that one. But it did offer one thing, and that was a major thing, which was to deliver more power to the components in the CPU. However, Intel canceled that standard in 2006 because they said they wanted to concentrate on the newer multi-processor, lower power CPUs. And so we're suffering now with every major release of a new processor. We're adding more and more connections, power connectors, to the motherboard of the ATX, because we don't have the BTX standard here that would have helped deliver more power to the board. What about the servers? So that standard is maintained by the Server System Infrastructure Forum, and their standard dates back to 1998, so it's not a whole lot better than the ATX standard. However, they did wake up in 2008 and develop a set of standards for blade systems. That includes all the components of the blade, from the actual blade itself to the blade chassis to the mezzanine, in order for you to be able, as a customer, to be able to exchange components with any vendor and utilize your blade chassis. IBM helped to develop that standard. Of course, they're out of that business today. Lenovo has that, and I'm not quite sure that they're following it, but I can assure you that none of the other vendors are following that standard today. It's not possible to exchange components on a blade center. So or a blade chassis, I should say. Blade Center is kind of a brand name. There have been minor revisions to the server infrastructure board, or the server motherboard as depicted here, and that's to, again, add additional power. They've also added additional lanes for PCI risers and so forth to be able to accommodate higher speed networking cards and also graphics cards. You'll also find power connectors on the board to be able to support the graphics power needs as well. So that's where we are with hardware, at least from the standpoint of the ones that we're all familiar with. What about the operating system? Now, I know Unix didn't run on PCs in 1969. Unix didn't appear on a PC until about 1983 or so. But from 76 forward, there was a huge amount of activity. Now, I don't have everything listed here. If I did, this list would be running all over the place. We would have CPM, CPM 80, MPM, MPM, and all the variants that Digital Research did. There was a number of variants from Tandy to Apple to IBM and on up. And we get into about, probably 1995 or so, and then the Windows changes over. NT and 95, Windows 95 are merged at that point. And one of the more interesting innovations was 2 years ago, actually 3 now, where Apple changed the name of Mac OS X to Mac OS, which is what it was originally in 1984. What an innovation. Anyway, as we had said, the main thing in the mid-70s until about the mid-1990s was that operating systems were rolling out with major changes to the hardware. We went from 8-bit to 16 to 32-bit platforms, all within a span of less than 20 years. And it was no regard for whether or not your applications would run, because they didn't really care. I mean, there wasn't that many applications, first of all, to worry about. And second, most people were writing their own anyway, so they just ported it. So what innovations? Now, that would be the early years, not the mid-'80s, okay? Things changed then, and we'll talk about that. So what innovations is Microsoft planning for this year? They're going to begin shipping an in-house built Linux kernel for Windows 10. So in case that's lost on you, let me explain that to you. So Microsoft is adding a 28-year-old innovation to Windows. And that 28-year-old innovation is in itself based on a 50-year-old innovation called Unix. That's back to the future. That is not innovation. I think it's time to recognize, as we did, software has a lifespan. That includes the operating system, the applications, the drivers, the utilities. We thought it'd be 10 years, when I started at least, that the applications would be obsolete because the hardware and the software would advance beyond the abilities of that software to cope. And so it'd be cheaper to just rewrite it for the new operating environment rather than porting it or trying to hold back the reins on innovation for the sake of programming. So what happened? Well, what happened was this happened, and I heard this many times when we were out and talking to customers and showing them new operating systems that we were bringing around when I was with Burroughs. Excellent operating system, but will it run Lotus 1, 2, 3? So here's the problem that happened. So Microsoft Windows and Microsoft DOS and PC DOS all had the ability within their operating systems to translate reads into memory, reads to the floppy disk, or if you're lucky enough to have a hard drive, they would translate that as well. The problem is that they were very slow. And so what happened, because IBM had published the PC BIOS, the vendors of the software, like Lotus, for example, and they're not the only ones, I'm not picking on them, there was just about everybody did it. They bypassed the DOS, Microsoft DOS and PC DOS calls. They went straight to the BIOS to do their reads and writes. Well, what happened then is that really tied that software to that platform. I mean, it was locked tight. And so anybody that's coming in with a new operating system, of course, wouldn't have an IBM BIOS, and so couldn't run Lotus 123 unless somehow you emulated it. So the industry at this time began to react in ways that were very strange to me. It was very foreign. I wasn't used to it. It was things like, we have to preserve the ability to run this large base of software. Okay, how many people are running Lotus 123 right now? How many people are running? Probably not anybody. It's gone. It's dead. Even the company is gone and dead. They were bought up by IBM years and years ago. It'll cost too much to move to a new platform, and yet you are. Whether you know it or not, you're moving to the cloud. You might still be using an obsolete PC, but out from underneath of you, all of the processing and heavy weightlifting is occurring on the back end. We can't afford to migrate, convert, or change. And again, yet you are. You're updating to new processors. You're updating to new motherboards. You're updating to new software that's running in the cloud, that's not running on your PC. And so I'm not buying that. That's not a good argument. Henry Ford is alleged to have said this. If I had asked people what they wanted, they would have said faster horses. And I think if you ask people today about what do you want from the next PC, I think they're always going to say, well, they'll probably hear a lot of different times, I want a faster PC. And yeah, I'm aware that Henry Ford, the controversy around whether Henry Ford said that or not, but that's not the point. The point is that he didn't ask. He went ahead and he built an affordable car that he knew people would want. And he was right. He bet the farm, he bet his entire financial future on building a car. And it turned out to work out. He sold a lot of them and became very wealthy. Innovation derives from the word invent. Invent means to create something that wasn't here before. Risk adverse is kind of the opposite. Risk adverse is you're not willing to invent, and therefore you're defeated. Because if you're not moving forward, you're a dinosaur. Sorry about that, but that's just the case. You're a dinosaur. Thomas Edison failed, according to Rutgers, 10,000 times throughout the course of all of his inventions. And 3,000 of those failures occurred with the light bulb. And in fact, in an interview in 1890, he said, I have constructed 3,000 different theories in connection with the electric light, each of them reasonable and apparently true. Yet only in 2 cases did my experiments prove the truth of my theory. So in other words, he was right twice out of 3,000 times. And so here's the question again. What's the price of a single failure in the company that you work for now? How do they react to that? Yeah, I've heard the other thing is that managers will say, but software costs more now. That's not true. That's not true at all, and don't buy that argument. IBM's System 360 cost $5 billion in 1961. That's hardware and software, and that would be $42 billion in today's money. Here's the real kicker. In 1961, IBM's revenues, not profit, revenues were $2.2 billion. They bet everything on the System 360. It was a calculated risk. They knew if they could pull it off, they would sell it, and they would sell a lot of them, and they did. And they're not the only ones that were like that. I mean, Lockheed did the same thing with some of their aircraft. Letourneau did a lot of things with the earth movers that he made. He bet the farm, invested heavily in things that he thought people would buy. So without innovation, human life stagnates. In today's corporate culture, we punish failure and we expect success. It should be just the opposite. We should expect failure and reward success. An example is 50 years ago, we had this weird idea to send a couple of human beings, in fact, to the moon. Never done it before. It was a huge risk. There were many failures along the way, many, many failures, but it ultimately was successful. So the question isn't about what's happened in the past. The question is, what do you plan to do? What do you plan to innovate? How do you plan to invent something new? Are you waiting on your company to give you permission? Because if you are, don't bother. I mean, chances are they won't bet any money on it. Go do it yourself. And so I'd like to end this with a quote from one of the first programmers, and that'd be Admiral Grace Murray Hopper. She said, the most dangerous phrase a DP manager, data processing manager, would be an IT manager today. The most dangerous phrase a DP manager can use is, we've always done it that way. Well, she says anyone can do things the way we've always done them. It takes brains to do and understand new things. It's more work to do something new than it is to do things the old way. And sometimes you find something faster and you find something better. So with that, I want to thank you for listening and watching my video. If you enjoyed this, please like and subscribe. And if you're so inclined, leave a comment. Happy to hear from you. Hope to see you again real soon, and bye for now.